So today we are going to see the basic setup of the cold plasma. That is the basic setup for needed for the cold plasma, that is known for the control panel, and in the back there is a step up transformer we will see later, and this is the overall setup for the cold plasma reactor, that is called dielectric barrier discharge cold plasma. Here we are using, if you can see, remove this panel, if you can see there is a, you can observe there is a multiple pin is setup, that is why it is called multiple arrangement cold plasma setup. In this setup we mostly use the atmospheric air, so that is the advantage for as compared to the other cold plasma setup, it is mostly use the atmospheric air and it is converted into the plasma. So before going for this demonstration, basically we go for some theory. In cold plasma is mostly initially used to deactivate the microbes by seeing their advantage in various food applications. Right now it is getting popularity due to its various advantages, such as you can modify the starch, proteins, and we can manipulate other proximate composition, as well as we can reduce the anti-nutritional factors also. So what happen when we apply the power voltage here in this multiple arrangement, the electron will be generated and it will be bombardment into the at the bottom plate. Here we can see there is a petri dish, we are putting the sample here up to the thickness of 2 mm, then it is carefully placed at the middle of the center. So due to that, whatever the plasma will be generated, that will be directly interact with the sample. So in this process there will be three phenomena will be happening. First, etching due to their reactive species, then bombardment will be happening due to this reactive species will be generated, because when we applying the high amount of electrical field, the electron will be generated here and it will be going down to the negative side, and then it will be interact with the product surface, and also due to this the oxidation process will be going on. So due to this three mechanism, the whatever went to microbes that can be eliminated and we can manipulate the molecular composition. Most importantly, in case of cold plasma treatment, we can interact or we can modify the non-covalent interaction, and here the covalent bond, it can be certainly reduced or it can be degraded, because the due to this cold plasma system, whatever the electron will be generated, it can contain the energy content up to the 5 electron volt, milli-electron volt, but we know that in case of any food material, it can be the covalent bond strength will be vary up to minimum is 8 milli-electron volt. So that it is clear that the cold plasma reactive species will not sufficient to break this covalent interaction, and it can break the non-covalent interaction. Due to this, whatever the strong interaction will be there, that can be broken up. So if you can see, when we are applying the high electric volt, so whatever the air will be there, that will be first ionized and it will be converted into the reactive species. In here reactive species, whatever the oxygen will be there and other atmospheric air composition, it will be converted into reactive oxygen species, nitrogen species, hydrogen peroxide and other reactive substance. It will be simultaneously go down at the surface, but the limitation is due to this bombardment, it can more effective at the upper layer of the sample. So here we recommended the sample thickness should not be high, so that we can get the better effectiveness. It also having certain limitation, because we need some high amount of electron voltage. For this setup, we can go up to the 70 kilovolt power supply, you can go minimum 1 kilovolt to 70 kilovolt. And another one factor is the distance between this electrode to this negative plate is also an important factor. If we increase the distance, we can increase the power also, but the effectiveness of the reactive species will be reduced. For here in this condition, the distance between the electrode upper surface to bottom plate, it is 7 centimeter and is found to be suitable under the voltage between 10 to 20 kilovolt. When we treat the sample, we get the better condition. So as we can see from this back, this is called step up transformer. So what happened in our daily use, we use the 220 volt power supply. Here this is step up transformer, it is mainly used to increase the voltage. Here the transformer is able to increase the temperature up to increase the voltage up to 70 kilovolt. Due to that, what we go, there is a two connection. This one is the green one is for useful to the earthing purpose, and red one is for the supply for the positive current. So this transformer can be used to treat the useful for operate the dielectric barrier atmospheric plasma, and it can also be used to generate the plasma activated water. See, this is the basic setup for the plasma activated water, where you can see this is a glass container where we are putting the water. So minimum recommendation is 1/3 of the total volume should be filled with the water before we are starting the plasma activated water. So maximum is we can fill as per our choice. Initially what happened, we fit there is an electrode, only one electrode is there for this plasma activated water. When you apply the electrical current here, due to this and then plasma will be generated and it will dissolve into the water, and then this pump will be recirculating the water. As a result of this, whatever the water is there, it will be rich source of plasma. And for this condition we want to note that the pressure value and the duration is also important, because if the pressure is not sufficient, it will not create the sufficient amount of plasma activated water. But the limitation of the plasma activated water, it because of the short shelf life, or you can say short stable. Here the maximum retention time for the plasma activated water up to 30 minutes. For that, for longer processing time, as of now the plasma activated water may not be suitable.